Bismillahirrahmanirrahim. It's me, Madam Sarvat Naz, Assistant Professor at Government Girls Degree College. Our subject is Introduction to Information Technology or Computer Sciences. Today's topic is buses. Buses, these are not the buses which we use in our traveling systems, but these buses are used to transfer the data from one component to the another component of the computer. So, the definition of buses is there are a number of possible interconnection systems, and single and multiple bus structures are most commonly used. Means bus structures are nothing but these are the wires which connect and hold the data and addresses and some instructions from one component of the computer to another component of the computer. So now what is a bus? A communication pathway connecting two or more devices is known as a bus. More devices share the same bus and usually broadcast, often grouped, a number of channels in one bus. Example 32-bit bus or 32 separate single bit channels. Now there are types of buses. A data bus can hold a data which can be your numeric data, alphanumeric data or alphabetical data, but it holds the data, audio, video or any type of data. Data bus carries the data. Remember that there is no difference between data and instruction at this level. Width is a key determinant of performance. It can be 8-bit, it can be 16-bit, it can be 32-bit or 64-bit. It works just like a water pipe. Have you seen the water pipes? If you use the wide water pipe, the more you get the water. If you use the narrow water pipe, you will get the same amount of water but in slow. Now the address bus. Address bus identifies the source of destination of data. Example, CPU needs to read an instructions or data from a given location in memory, and bus width determines maximum memory capacity of system. Example, 8080 has 16-bit address but giving 64K address spaces. Address are the memory locations from where the data or instructions can be retrieved or can be sent. These are the locations. Addresses are just like your home addresses, just like you get the parcels or your addresses. You know that your whole community, or you can say that your whole city or your whole community has some different locations. Your house number can be changed from another's house. So that's why the address bus can also carries the addresses of the locations in the memory. Now another bus is used as control bus. Control and timing information. Sometimes memory read or write signals can be sent through the control bus. Either we can read from the memory or we can write over the memory. Some signals can be sent to the memory locations. And interrupt requests. Sometimes we have to wait somewhere. So these are the interrupt. Hold, wait and ready. These are the interrupt requests. And clock signals. Clock signals are nothing but these are the timing signals. These also known as the control signals. So control bus controls the timing of information, memory read or write signals, and interrupt requests and clock signals. It is just like you can control our mind can control your whole body. I have already told you in the CPU, control unit controls all the activities of the processing. That's why the control bus can hold these type of the control signals. Now there is a structure of bus interconnection scheme. Buses are connected with the CPU, memory and other location at the memory and input and output devices. And these type of buses are known as the control bus, control lines, address lines and data lines. These are the three type of buses which are also connected with each and every device, memory device, input and output device or CPU. Every device is attached to the bus and it needs to be coordinated. Big and yellow. What do buses look like? This is a type of a bus and this is the structure. Here is the CPU and then memory and then input and output devices. So the structure is just like the front yellow look of your bus, and these are the connectivities among the buses. Now single bus problems. As you know that a single way can hold a lot of a single line of traffic can hold a lot of traffics, then a single bus can also have some problems. Lots of devices on one bus leads to propagation delays. Large data paths means the coordination of bus uses can adversely affect performance. If large data can be carried on a single bus, it can delays or it can take some time, and it aggregate data transfer approaches bus capacity. Most systems use multiple buses to overcome these problems. So single bus can have much more problems, so we have to overcome such type of problems. We use the multiple buses. Now traditional with cache. Now a local bus can carry processor and cache and local input output controller, while a system bus can carry the main memory, a connection between the main memory, cache and the processor, and that system bus is also connected to the expansion bus interface. Expansion bus interface is the connectivity or you can say that the multiple connectivity of the buses which can be networked, SCSI, modem and serial buses, and these are known as the expansion buses, which can hold the data, signals and connectivities to the system bus, and system bus can provide the connectivity to the main memory and the cache memory and to the processor. Now these expansion buses can also be used for high performance buses. The local bus can travel from processor to the cache, and the system bus from main memory to the cache, and a bridge between the high speed buses and expansion buses, where you can see that some fax machine, some modems, some serial devices, some lanes, some videos and some graphics are also connected to the high performance buses. These are the multiple type of buses. Now what are the main bus types? Some buses are dedicated. Dedicated means separate data and address lines, and some buses are multiplexed. Multiplexed means shared lines, address valid or data valid control lines. Advantages: these are the fewer lines, and disadvantages: more complex control and ultimate performance.